Alright, so this is a test review for test number 1. Problem number 1 says convert the angle to a decimal in degrees. So the angle measure is given in degrees, minutes, seconds. The whole number part is the degree part, plus we need to change the minutes over to degrees. 59 minutes times 1 over 60 degrees, because 1 minute is 1/60th of a degree. Plus, now we need to change the seconds over to degrees. 21 times 1 over 3600. And that's because 1 second is equal, or I'm sorry, 1 degree is equal to 3600 degrees, seconds. So, I definitely use a calculator on this. 59 divided by 60. That's 0.983 repeating. 21 divided by 3600. What was it, 0.983? Is that what I said? 0.983 repeating. Oop, not 2. Alright, and so that's what the second term and the third term are equal to. If you add those together, plus the whole number part. The directions say to round to 2 decimal places, so that is going to round up. You see the second decimal place is an 8. There's a 9 after it, so it's going to be 75.99 degrees. And that's your final answer. The next problem is to take a decimal in degrees and convert that to degrees, minutes, seconds. So the whole number part is the degree part in degrees, minutes, seconds. They want to take the decimal part of 0.23 and change that over to minutes. So we say 0.23 times 60 minutes. It's 13.8. So it's going to be 13 minutes, and then we're going to take the 0.8 and change that over to seconds. 82 degrees plus 13 minutes plus, we're going to change the 0.8 over to seconds, so it's 0.8 times 60 seconds, because that's 0.8 minutes, and there's 60 seconds in 1 minute, so you multiply by 60 seconds. That gives you 48, so that's 48 seconds. So it's going to be 82 degrees, 13 minutes, 48 seconds. The next one is finding the arc length. Arc length is S equals R theta, where theta must be in radians. We're given R equals 8.3 inches. Theta equals 300 degrees. What is the arc length? So change 300 degrees over to radians first. You do that by multiplying it by pi over 180 and simplifying. Alright, so you can divide both of those by 30, and you'll get 10 pi over 6. And that reduces 5 pi over 3. Alright, so that's what we plug in our formula for the angle. The radius was 8.3. So S equals 8.3 times 5 pi over 3. I would suggest using the pi button, but if you don't, use 3.14159. The test, all the answers are rounded to one decimal place on the test, so 8.3 times 5 times pi, and then that divided by 3. Alright, so if I round to one decimal place, that's 43.5. Number 4 is convert degrees to radians. We just did that. You multiply by pi over 180 and simplify. So you can divide the numerator and denominator by 90, and you get pi over 2. Number 5 is convert the angle in radians to degrees. 6 pi over 3. Instead of multiplying by pi over 180, you multiply by 180 over pi. See, the pi's cancel out. The 3 and the 180 cancels out, makes that a 60. So we have 6 times 60. That's 360 degrees. For number 6, we want to convert 5 pi over 6 to degrees. So multiply again by 180 over pi. The pi's cancel out. You can cancel out between the 6 and the 180. That will leave 30. And so that's 5 times 30. That's all that's left. That's 150 degrees. Number 7 is an area problem. The area of a sector of a circle. That formula is area equals 1/2 r squared theta. The problem says that r equals 14 inches, theta equals 5 radians. What is the area? So area is 1/2 times 14 squared times 5 radians. So you could say 14 times 14, get 196, times 5 times 1, because that's the numerator of the fraction, and then divide by 2. So that is 490 square inches. Number 8 is also an area problem. We're given in number 8 that the angle measure is equal to pi over 4. The radius is equal to 9. And we want to round our answer to 3 decimal places. Area of a sector of a circle is 1/2 r squared theta. So that's 1/2 times 9 squared times pi over 4. Alright, so that's going to be 81 times 1 times pi. So that's 81 pi divided by 2 times 1 times 4. That's 8. Again, I would use the pi button if you have one of those in your calculator. 81 times pi divided by 8. Alright, so that, if we round to 3 decimal places, it's going to be 31.809. Alright, and that was in feet, so that's square feet on that problem. The next 3 problems are like the very first problems where we evaluated trig functions, where we let t correspond to some point P. Alright, and so these were when we first defined the 6 trig functions, and we knew all these points were on the unit circle. So they're all pretty straightforward. The point on number 9, 4/7 square root of 33 over 7. It says find sine of t. We said sine was the y coordinate. If we're on the unit circle, it's just the y. So the y here, square root of 33 over 7. And we're done. That's the answer. Number 10, we have the point square root of 33 over 7, 4/7. We want to find secant of t. Secant's 1 divided by x. 1 divided by x. So that's 1 divided by the x coordinate is square root of 33 over 7. So flip and multiply, and you'll have 7 over the square root of 33. And then rationalize. Multiply the top and bottom by the square root of 33, and we'll have 7 square roots of 33 over 33. Number 11, the point 5/7, negative 2 square roots of 6 over 7, says find cosecant of t. Cosecant is 1 over y, as long as we're on the unit circle. So that's 1 over negative 2 square roots of 6 over 7. Flip and multiply, that's going to be negative 7 over 2 square roots of 6. Rationalize, I'm multiplying the numerator and denominator by 6, by the square root of 6. And that's going to be negative 7 square roots of 6 over, in the denominator we already have a 2. Square root of 6 times square root of 6 is 6. 2 times 6 would then be 12. You can't simplify between the 6 and the 12, so that's your answer. Problem number 12 is similar to this, except this point is not on the unit circle. Remember, that's x and y. If the point is not on the unit circle, then that's where we have a r, a radius. Okay? If we do need to find r in this problem, we use the formula x squared plus y squared equals r squared. Alright, but the problem asks us to find the tangent of theta. If this point, negative 3, 2, lies on the terminal side of our angle measure. In terms of x, y, and r, tangent is y over x. So we don't need to find r for tangent. The y coordinate is 2. The x coordinate is negative 3. So the answer is negative 2/3. That's the final answer. Number 13, the sine of 45 degrees. Remember, 45 degrees is the same thing as pi over 4. We associate the point square root of 2 over 2, square root of 2 over 2, with 45 degrees, or pi over 4. Sine is the y-coordinate. So the sine of 45 degrees is the square root of 2 over 2. Number 14, cosecant of pi over 3. Pi over 3 is the same as 60 degrees. We associate the point 1/2 square root of 3 over 2. Is that right? Okay. With pi over 3, or 60 degrees. Cosecant is equal to 1 over y. So 1 over the y-coordinate is square root of 3 over 2. So you flip and multiply, and you get 2 square roots of 3 all over 3. And that's your answer. Number 15, the cotangent of 390 degrees. 390 degrees is larger than 360 degrees. Anytime we have an angle measure that is larger than 360 degrees, we can subtract 360 degrees from that. That goes one complete revolution around. So the cotangent of 30 degrees is the same as the cotangent of 390 degrees. Now, 30 degrees, we associate that with the point square root of 3 over 2, 1/2. Cotangent is x over y. So this is the square root of 3 over 2 over 1/2. Flip and multiply, the 2's cancel out, and I'm just left with the square root of 3. Alright, number 16, the sine of 135 degrees minus the sine of 270 degrees. So I have two problems to work out, and then I'm subtracting. First, to find the sine of 135 degrees, we need to figure out two things. Which quadrant is the sine of 135 degrees in? Because then, using the salty C chart, I can tell if the answer is going to be positive or negative. Then we need to use the reference angle chart to figure out the reference angle. If we know the reference angle, then we know which point to use, and we can get our answers. So 135 degrees is going to be in the second quadrant, because 135 degrees is between 90 degrees and 180 degrees. When you take the sine or cosecant of something in the second quadrant, it's always positive. So that means that when I take the sine of 135, that's going to be a positive answer. Okay? The way that I find that answer is I use my reference angle chart and look at the formula in the second quadrant, since that's where we are. So let's figure out the reference angle for 135 degrees. To do that, you say 180 degrees minus theta equals 135, and find the reference angle. Solve for theta. That's the reference angle. So subtract 180 degrees from both sides, and I'll have negative theta equals negative 45 degrees. Or if we divide both sides by negative 1, theta, my reference angle, is 45 degrees. When you solve for the reference angle, you should always get 30 degrees, 45 degrees, or 60 degrees. That's when it's 45 degrees. That's the point, square root of 2 over 2, square root of 2 over 2. We associate that with. So now, sine is y-coordinate. We've also said that the answer is going to be positive. The y-coordinate is square root of 2 over 2. So the sine of 135 degrees is a positive square root of 2 over 2. Minus the sine of 270 degrees. 270 degrees is a quadrantal angle. The way we can remember that the values for the quadrantal angles is by using the unit circle. 270 degrees is on the negative y-axis on the unit circle. That's the point 0, negative 1. That's your x and y. Sine is the y-coordinate. So the sine of 270 degrees is a negative 1. So we had minus negative 1. So that's square root of 2 over 2 plus 1. Now that answer is probably not down there because we have two terms. So a lot of times we won't see an answer listed like this. We would see just one fraction. So that's getting a common denominator of 2. This first thing already has a denominator of 2, so that would be square root of 2. Then plus, now to put this number up in the numerator, since there's a 2 on the bottom, I have to say 2 times 1. So that'll be 2. So square root of 2 plus 2, all divided by 2. That's your final answer. Alright, number 17. Secant of theta is less than 0, and tangent of theta is less than 0. Name the quadrant in which the angle lies. So when I'm working one of these, I bring up my salty C chart. Now, secant is less than 0, so that means what we want to do is we want to say which quadrant is secant negative. Which quadrants? There are 2. So secant is positive in the first quadrant and in the same quadrant as its reciprocal, which is cosine. So it's negative in the second and third. Where is tangent negative or less than 0? Tangent is negative in the second and fourth. So which quadrants does that overlap? The second. That means theta is in the second quadrant. Right, number 18. We're told sine of theta equals 1/4. Cosine of theta equals the square root of 15 over 4. Find secant of theta. The easiest way to work this out, I could find x, y, and r and then use that, but the easiest way is to use the reciprocal identity. Remember, secant is 1 divided by cosine of theta. So that means secant is equal to 1 divided by the square root of 15 over 4, because that's what cosine is equal to. Or you just take the reciprocal, 4 over the square root of 15. Rationalize, and you get 4 square roots of 15 over 15. Number 19, we have cosecant of theta equals negative 9/4, and we're told we are in quadrant 3. That's very important. We want to find cotangent. Alright, so the problem told us that we're in quadrant 3. That is down here. In quadrant 3, the x's are negative and the y's are negative. Okay? That's important where if we need to find an x or a y, we'll know to make it negative. Alright? We were given cosecant of theta equals negative 9/4. Remember, cosecant is also equal to, in terms of x, y, and r, it's r over y. R can't be negative. It's a radius. So the r for this problem, the radius, is 9. That's what's in the numerator. There is a negative in front that needs to go with the y. So y is equal to negative 4. Alright, the cotangent is x over y. We don't have x, so we need to solve for x. To solve for x, we use the formula x squared plus y squared equals r squared. So x squared plus negative 4 squared equals 9 squared. Or x squared plus 16 equals 81. To solve for x squared, we subtract 16 from both sides. So I get x squared equals 65. Take the square root of both sides. This is where we would usually get plus or minus the square root of 65. But we know we're in the third quadrant, so we don't need plus or minus, we just need the minus. So it's negative square root of 65. So now we're almost done. We found what x was equal to. It was equal to negative square root of 65. Cotangent is x divided by y. So x is negative square root of 65. Y is negative 4. So I have a negative over a negative. That's a positive square root of 65 over 4. That's my final answer. The last problem on the review, number 20, says use the even-odd properties to find the exact value of the expression. Do not use a calculator. The even-odd property for tangent says that if you take the tangent of a negative angle measure, like negative 30 degrees, that's equal to the negative of the tangent of the positive angle measure, 30 degrees. So what's the point we associate with 30 degrees? It's going to be square root of 3 over 2, 1/2. Now remember, tangent is equal to y divided by x. So this answer is going to be, I have a negative in front, I can't forget that. It's going to be negative y divided by x. So negative 1/2 divided by square root of 3 over 2. So I need to take and flip. So that's going to be negative 1 over square root of 3. When you rationalize, be equal to negative square root of 3 over 3. That's your answer.